In the previous session, we looked at substitution method briefly. Now let's dig into it a little bit deeper. Now integral of x squared dx is equal to x cubed by 3 plus c. We have already seen this as a standard integral. Remember, integral x to the power of n dx is equal to x to the power of n plus 1 by n plus 1 plus c. So just in case, let's verify this. Differentiating the right hand side, we get 3x square by 3, which is equal to x square, which is what is there under the integral. Okay, but how about if we substitute x with the natural log of absolute value of x? Then can we use the same formula? If we use the same formula, we end up with natural log cube of absolute value of x divided by 3 plus c. Let's see whether this is correct. By differentiating the right hand side, what do we get? We get 3 natural log square of absolute value of x divided by 3 times 1 by absolute value of x times 1 chain rule. If we simplify this, we get natural log square of absolute value of x divided by absolute value of x. Now, this is not equal to this. Why? Primarily because we have an additional element because of the chain rule. So here, x to the power of n dx integral is equal to x to the power of n plus 1 by n plus 1 plus c does not apply. Let's look at another example. Integral of x square plus 1 to the power of 3 dx is equal to x square plus 1 to the power of 4 by 4 plus c. Applying the formula blindly. Let's verify. Differentiate the right hand side. So when we differentiate, we get 4 times x square plus 1 cube times 2x by 4, which is equal to 2x times x square plus 1 cube. Again, you notice we have an additional element, 2x, because of the chain rule. So here again, it is not what we expect. So here, what is the difference? Here, instead of x, we have natural log of x. So the integral is of a function of x rather than of x itself. Same is the case here also. So the steps goes like this. Given an integral, use standard integral formulas. Verify the integral by differentiating the result. And if verification fails, use another method. Now, what are these additional methods? We have integration using substitution method, integration using partial fraction, integration by parts, reduction formula, duplication formula. So let's look at the substitution method in more detail. If an integral has both f of x and f prime of x dx, we can do the substitution u is equal to f of x. Given integral f of x times f prime of x dx, then let u is equal to f of x. Now we also require du, so let's differentiate u is equal to f of x. We get du by dx is equal to f prime of x, which means du is equal to f prime of x dx. And now we do the substitution. So when we do the substitution, we get integral of u times du. And we know the integral of u du is equal to u square by 2. Now, substituting u with our original substitution, we get integral of f of x times f prime of x dx is equal to f square of x by 2 plus c. Now that's integral of f of x times f prime of x dx. This is not the only form in which we might get a integral. We might get something like this. I is equal to integral e to the power of f of x times f prime of x dx. So here we don't have f of x times f prime of x dx. F of x is in the exponent and f prime of x dx is in the usual as a product. Okay, so here what substitution do we make? Again we do u is equal to f of x. So du is equal to f prime of x dx. So substitution, if we carry out, we get integral e to the power of u times du, and we know the integral of e to the power of u, so which is e to the power of u plus c. And now we substitute u with the original assignment. So e is equal to e to the power of x plus c is a integral of e to the power of f of x times f prime of x dx. Okay, second one. I is equal to integral of sine of f of x times f prime of x dx. A little bit more trickier, but f of x is there and f prime of x is also there. So u is equal to f of x. So du is equal to f prime of x dx. We get after substitution integral of sine u times du. And we know the integral of sine u, which is minus cos u plus c. Substituting back, we get integral of sine of f of x times f prime of x dx is equal to minus cos of f of x plus c. Let's look at the third one. Integral of f prime of x dx divided by square root of a square minus f square x. After substitution, we get integral of du by square root of a square minus u square, which is equal to, we know, integral of 1 by square root of a square minus u square du is equal to sine inverse of u by a plus c. Again, we substitute back u. So this is equal to sine inverse of f of x by a plus c. Let's look at the fourth one. Integral of f prime of x dx divided by square root of f of x square minus a square. Pretty straightforward. U is equal to f of x, du is equal to f prime of x dx. After substitution, we get integral of du by square root of u square minus a square is equal to natural log of u plus square root of u square minus a square plus c. This is the standard integral, which is equal to natural log of absolute value of f of x plus square root of f of x square minus a square plus c. Now remember here very importantly that in definite integrals, limits are involved. So whenever we do substitution, we have to take care of the limits. We have to change the limits based on the substitution. Okay, fifth one. Integral of f prime of x dx divided by square root of f of x square plus a square. U is equal to f of x, du is equal to f prime of x dx. After substitution, we get integral of du by square root of u square plus a square, which is equal to natural log of u plus square root of u square plus a square plus c. Don't forget to put in the absolute values at least in the last step. So equal to natural log of absolute value of f of x plus square root of f of x square plus a square plus c. Let us look at the sixth one. Integral of f prime of x dx divided by a square minus f square of x. So again, u is equal to f of x. So du is equal to f prime of x dx. Now carrying out the substitutions, we end up with integral of du by a square minus u square, which we know is equal to 1 by 2a natural log of absolute value of a plus u by a minus u plus c. So finally we get 1 by 2a natural log of absolute value of a plus f of x by a minus f of x plus c. Seventh one, integral of f prime of x dx divided by f square of x minus a square. So again, u is equal to f of x, du is equal to f prime of x dx. So after substitution, it becomes integral of du by u square minus a square, which is equal to 1 by 2a natural log of absolute value of a minus u by a plus u plus c. Again, substituting back u. So 1 by 2a natural log of absolute value of a minus f of x by a plus f of x plus c. So basically what is happening in all this is that by doing this substitution, we are getting a standard integral whose result we know. Eighth one, integral of f prime of x dx by f square of x plus a square. So u is equal to f of x, du is equal to f prime of x dx. After substitution, we get integral of du by a square plus u square, which is equal to 1 by a tan inverse of u by a plus c, which is equal to 1 by a tan inverse of f of x by a plus c. Of course, without doing the actual substitution, if you can visualize the pattern, then of course you can directly arrive at the result. Ninth one, I is equal to integral of f prime of x dx divided by f of x. So here, can we visualize this? We have f prime of x dx by f of x. So we will have what? du by u, or 1 by u du, which we know is natural log of u. So let's see whether we are right. So u is equal to f of x, du is equal to f prime of x dx. After substitution, we get integral of 1 by u du. And we know the integral. So integral of 1 by u du is equal to natural log of absolute value of u plus c. And bringing back x, we get natural log of absolute value of f of x plus c. So that is the substitution method. We will look at many more in our next session. Again, let me remind you, there is a link to a PDF book which describes all these in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.